Hello DSci 2000. In this video, we will be continuing Unit 3 and I will be covering an introduction to R. Here's the usual objective slide. Please pause and read before proceeding. So to begin, what I'm going to do is as follows. I'm going to open up my DSci 2000 folder and I'm going to create a new folder in here and we're going to call it, in all caps, data_files. In D2L, what I have done for you is I have gathered data in a file called simulated_mn_salaries.csv. Please download this file and save it to the data files folder that you just created. Now that we have downloaded the file, let's just go back to the DSci 2000 folder and open up the rproj file. Please close any code windows you have open and go to File, New File, and then rscript. I'm going to save this file to the Unit 3 folder, and I'm just going to call this Intro to R. Now the first thing I'm going to do is I'm just going to follow the code that is in this slide. So what are we doing here? We're going to take that simulated MN salaries file that you just downloaded and read it into R. This is exactly how you do it. So let's go ahead and type this code directly into RStudio. And then once you've typed in the code, press Control Enter. I'm going to zoom out. And I'm going to go to the right over here to the Environment tab and click on DF. I'm going to scroll left to view the contents of this table. So this is a table consisting of people's salaries over multiple years. Each person is uniquely identified by an ID, and the year is a unique identifier for the value here, which is the salary. So these data are tidy. The composite primary key, which uniquely identifies every row, is the ID and the year. So the ID and year constitute a composite primary key for these data. I'm just going to close this right now. We're going to go a little in depth in terms of what it is we just did. So that table we just viewed, this table here, is called a data frame. A data frame is two-dimensional. It consists of rows and of columns. If your data are tidy, your rows should consist of individual observations, and your columns should consist of attributes of each observation. The data frame is the fundamental structure that R uses for reading in data. If you have data that are structured like a table, you can make that into a data frame into R. R is really built for handling tabular data. For other kinds of data, tools like Python might be more appropriate depending on the type of data you want to work with. So this is an excerpt of that data frame that we just looked at. Head, when you execute it on a data frame, displays the first 6 rows of a data frame. How you can execute this is as follows. I'm going to go to the top left over here and go back to my code. And I've already executed line 1 to view the data frame. I'm going to type in head, df, and then I'm going to press Control Enter to execute that code. And remember, code is always executed in the console in the bottom left. So head df is showing the first 6 rows of that particular data frame. Let's talk about how data frames work. If df is a data frame, df bracket I comma j refers to the ith row and the jth column. And note that R uses 1 to represent the first in an index, as opposed to other programming languages. In languages like C, C++, Java, and Python, 0 is generally used to mean the first index. In R, the first index is 1. So as an example, I'm going to go to my code on the top left over here. I'm going to type in df bracket 1 comma 1 and press Control Enter. On the bottom left here in the console, I can see that df bracket 1 comma 1 gives me 99994. This refers to the first row and first column value. The first row and first column of this data frame is right here. So that's where the 99994 comes from. So just remember, df 1 comma 1 refers to the first row and first column of df. Next, I'm going to type in df bracket 1 comma 2. This refers to the first row, second column of df. If I put my cursor there and I press Control Enter, and I zoom out and go back to the console, df bracket 1 comma 2 refers to the first row and second column of df. So if I look at the data frame, here's the first row, row 1, and here's the second column. So that's where that value of 2008 is coming from. And you could generalize this to any number of indexes that are available in the data frame. So for example, df2 comma 1 is the second row, first column, and df2 comma 2 is the second row, second column. The second thing you need to know when it comes to indexing data frames is that when you omit an index, all values are selected by default. Now I'll show you what I mean in a second. If I go back to my code up here on the top left, and I type in df bracket 1 comma, this will give me the first row and all columns of df because I have omitted the column index of df. If I zoom out and press Control Enter, I'm going to go to the console on the bottom left over here, and I can see that the entire first row of df is displayed under df 1 comma. So df 1 comma refers to the first row or all columns of df, or said more succinctly, simply the first row of df. Similarly, and I'm going to go back to code up here, I could type in df bracket comma 1. This refers to all rows but the first column of df. I'm going to press Control Enter, and I'm going to go to the console over here. You can see that it has quite a few values. Here's where the beginning of that first column is. This is the entire first column of df. If we look back and scroll up through the console, it's just showing everything that is in the ID column of df. So that's what df comma 1 refers to. It's just the entire ID column of df. And you can extend this principle to whatever index you want. df2 comma is the entire second row, and df comma 2 is the entire second column. The next thing you should know about a data frame is that if you use the attributes function on a data frame, it will tell you various things about the data frame that you should know about. For those of you who are familiar with object-oriented programming, you'll observe that a data frame is just a class, and that this class consists of several public variables that you can manipulate, such as names, which represent the column names of the data frame, as well as row names. What do I mean by this? If I look back at the data frame in the console in the bottom left, I can see that these values right here are the names of the data frame when you compare it to the slides, and the row names are these 1, 2, 3, 4, 5, 6, representing row identifiers for each row. So from this slide, the only thing I really need you to get from this is that data frames have attributes that come with them, and you can see what they are if you just do attributes df, consisting of the column names, the class of the object, as well as row identifiers. And I'm going to execute this code on the top left over here. I'm going to press Control Enter, and if I zoom in on the bottom left, I can see the attributes. These attributes actually serve as functions, which you can use to obtain the attributes directly. For example, recall that I mentioned that names is one of the attributes of df. You can actually, in the code, type in names df and press Control Enter to just extract the column names of df. For those of you who are familiar with object-oriented programming, this would probably be notated as df.names. R is not designed to look as if it were an object-oriented language. This different way of thinking is called functional programming. I might cover this a little more when we cover Python in this class, but the basic idea is that whenever in object-oriented programming you write df.something, in R, the analogous one is to, instead of viewing names as a property of df, you view names as a function of df that you use to extract the column names. You can also extract the class of df using the class function. And as I mentioned earlier, class is an attribute of the data frame df. Here are some other functions that you might find useful. I'll execute one or two of these. nRowDF gives the number of rows of the data frame. nCallDF gives the number of columns of the data frame. dimDF gives two values, both the rows and the columns. And strdf just gives you a brief glance of what the structure of df looks like. So I'm just going to execute nRowDF up here. I'm going to type in nrow df, press Control Enter, and if I scroll down to the left over here, I can see that df has this many rows. Before I forget, I'm going to go to my code, and the file name is in red. I'm just going to save it. And just to make sure you establish a habit of adding files to Git and committing them, I'm just going to go ahead and save this to my Git repository. I'm going to open the DSci 2000 folder, right click, go to Git bash here, cd to the unit 3 folder, and I'm going to git add intro to r.r. Those slashes, just so you're aware, are just there because there are spaces in the file name. That is how Git will know that you have a space in the file name. I'm going to press enter, and then I'm just going to do an initial commit on this. So we've now committed the file. I'm just going to go back to RStudio. Let's go on to the next slide. An alternative to names that I personally prefer is call names, standing for the column names of DF. Press Control Enter, and you can see in the bottom left right here that the column names of DF have been returned. What is being outputted by call names is a one-dimensional vector. Data frames are two-dimensional in that they have rows and columns. Call names DF, which just returns these 5 strings, is one-dimensional. In R, one-dimensional objects are vectors, and two-dimensional objects are data frames. The reason why this is one-dimensional is because there are no obvious rows or columns. We talked about two-dimensional indexing with data frames already, with the brackets and the 2 numbers separated by a comma. Because vectors are one-dimensional, you only have one number that should be inserted inside a bracket after it. For example, if I type in call names df bracket 1, this refers to the first entry of the vector call names df. I'm going to press Control Enter. I'm going to scroll down. You can tell that if you were to look at the first entry of call names df, that the first entry was the ID string, and that is exactly what's being returned when we throw a bracket 1 right after call names df. And the reason why we have only a single number in there is because call names df is a vector, which is a one-dimensional object, as opposed to data frames, which are two-dimensional objects. And similarly, call names df2 refers to the second component of call names df, which would be the year string. R has the following logical operators. These should be familiar to you from prior programming experience. If you have any questions about these, please let me know. Similar to other programming languages, you can use these logical operators to return Boolean values true and false, depending on whether the condition provided by the logical operator is true or false. For example, if I go back to R and I type in 5 is greater than 6, I'm going to press Control Enter. And if I look on the bottom left, I can see that R has returned the Boolean false. And you can extend this using other logical operators as well. 5 is of course not equal to 6, so that returns false. Recall also that the logical operator not, given by the exclamation mark, just gives the opposite of what is provided by the logical statement right after. So 5 equals 6 is false, so not 5 equals 6 would be true. You can use parentheses to combine logical operations. For example here, this is testing for 5 is less than 6 or 4 is less than 5. Since at least one of those is true, this logical statement returns the Boolean true. Let's go ahead and do this one in R. So we have parentheses 5 is less than 6 or 4 is less than 5. Press Control Enter, scroll down, and that returns true. One of the things that you will have to get acquainted with once you start using R a lot is that with things that you would usually do with a loop in another language, there's probably a function that you can execute in R that avoids loops entirely. For example, let's say I wanted to look back at my call names of DF. And recall that call names of DF has these 5 values: ID, year, salary, sex, and race. Let's say that I wanted to test whether any of the components of call names DF is equal to the year string. Here's how you would do that. Ordinarily, in most other programming languages, what you would do is you would write a loop to go through all of the call names of DF and see whichever one of them is equal to year. R conveniently provides a function to allow you to do this without writing a loop. How you would do this in R is you would say any call names df equals, in double quotation marks, year, in all caps. I'm going to click at the end of this line and I'm going to press Control Enter. And you can see here that when I execute any call names df equals year, I get true. Because what this is trying to do is as follows. It's looking through call names of df and it's seeing if any of the components of call names df is equal to year. That is how you would do this in R, as opposed to another programming language where you would ordinarily write a loop to do this for you. In R, there's also a function called all. I'm just going to type in the same thing as I typed in earlier, except switching any with all. I'm going to go to the end of the line and press Control Enter. I'm going to scroll down. And what is this saying? It's asking the following question. If I look throughout all call names of df, are they all equal to year? Obviously that isn't the case, so what this function returns is the false boolean. And in this slide you can see a few more examples of other things you can do, as well as how they translate to regular questions. Let's talk about pulling columns of a data frame. Let's go back and just take a quick glance of the contents of df. I'm going to scroll left. And I can see that df has 5 particular columns. Let's say, for example, that I wanted to pull the year column of df. The construction of how you do that in R is as follows. I'm going to go back to my code, and I'm going to type df $year. And you can press tab to autocomplete once you've selected it. I'm going to press Control Enter, and if I zoom out and go to the console, I'm going to scroll up a bit to where I typed in my code, and this is the entire year column of df. And of course you can combine this with either the any or the all function that I just mentioned earlier. For example, let's say that I wanted to test if all of the values in the year column are greater than 2007. How I would do that is as follows. All df $year greater than 2007. And press Control Enter. I'm going to scroll down, and this is telling me that yes, that is true. All values in the year column of df are greater than 2007. Additionally, you could use, instead of df $year, you could use df bracket comma year in a string and then end with a bracket. You're basically treating the year string as if it were a column index. Remember, ordinarily we would have a number in here, and in this case I'm just going to use a string instead to indicate that I want to pull the year column of df. Let's go ahead and run this code, and I'm going to have df bracket comma in a string year. I'm going to press Control Enter and scroll down, and indeed that's just the year column again. So there are 2 ways you can pull a column. You can either use df $, the column name, or df bracket comma and then the column name in single or double quotes. Here are some other things that you're going to need to know about for future homework assignments. You can create blank data frames that have no data in them. How you would do that is you would use the data frame function and then specify for each column its name on the left and the data type of the column on the right. In R, strings are characters and numbers are numeric. So this is generating a blank data frame with 4 columns: statistic, month, year, and value. And the statistic is a character or a string. The month is a character or a string. The year is a character or a string. And the value column is a numeric column. This is assigning to the out variable a blank data frame consisting of 4 columns. Let's go ahead and just demonstrate this. I'm going to go back to my code, and I'm just going to type in out, the assignment operator, data frame, and I'll just create a 1 column blank data frame. Statistic equals numeric. And don't forget that numeric is a function. I'm going to press Control Enter. I'm going to zoom out, and I can see on the top right over here that out has been created with no observations and 1 variable. If I were to click on out and scroll left, it would just tell me that there's this statistic column but there's no data available in the table. I'm going to go back to my code. It might not be obvious why you need this right now, but in the next video I hope it is more clear. But just know that this is how you create a blank data frame. I'm not going to demonstrate this right now, but if you want to combine two data frames and stack them on top of each other through rows, you can use what is known as the rbind function. You can use rbind on two different data frames and stack them on top of each other, assuming that they have the same column names and column data types between the two data frames. For loops are very similar to those that are in C. For example, in R, if you want to execute a loop, you have to create a vector of counters explicitly. For example, if you wanted to loop through I equals 1 to I equals 5, what you would have to do is you would have to say for I in 1:5. 1:5 refers to the vector of integers from 1 through 5, as you see here. So you actually have to explicitly specify this in your loop, as opposed to other programming languages like C and C++. Here's an if statement in R. This is just code that's saying assign the value x1. If x is greater than or equal to 3, print yes, otherwise print no. Here's how you declare a function in R. This here is a function called add2. What this does is it's taking an input x and it's returning x plus 2. Thus, after you execute the definition of this function, you can write add2 on 4 and get 6. Let's go ahead and do this in our code. So I'm going to create an add2 function. How I do that is I got to declare the add2 variable, assign it function x, and then curly braces. And then I'm going to type in here return x plus 2. And how you tell R to assign the variable add2, you just click anywhere on the line where you're declaring the variable, and you press Control Enter. If I zoom out and look on the right, I can see that the add2 function has been declared. After the add2 function has been declared, if I go back to my code, I'm just going to type in add2 on 2 and press Control Enter. This, of course, when you look on the console, returns the value 4. So that is how you declare a function in R. Generally speaking, and you'll see why this is later in this class, functions should be used in most cases where you're doing something repeatedly, but you have something that can vary. One of the things I really want to discourage in this class is code redundancy. Make sure you get into the habit of writing functions whenever you're doing something redundant but might vary just slightly depending on an input. And I'll provide more practical advice on this as we go through the class. There are going to be some situations where you want to generate vectors that don't necessarily increment by 1. For example, in such situations, you will want to use the seq function, standing for sequence. Seq from 1 to 5 by 2 generates a sequence of numbers from 1 to 5 incrementing by 2, i.e., the odd numbers from 1 through 5. Let's go ahead and execute this in our code. seq from equals 1, 2 equals 5, by equals 2. I'm going to press Control Enter. If I scroll down, I can see that this does indeed generate a sequence of integers from 1 all the way to 5 and incrementing by 2, which are just the odd numbers from 1 through 5. Similarly, if I just change the from 1 to 2, what this does is it generates all integers from 2 to 5 and incrementing by 2. So what this does is it generates the numbers 2 and 4, and it notices that when it goes beyond 4, that it exceeds 5, so it just stops there. Some other things you can do with numeric vectors. You can use the rep function. Rep stands for repeating. In this example right here, recall that 1:5 is just the vector 1, 2, 3, 4, 5. Rep on that vector with each equals 2 does the following. It says take every component of 1 through 5 and repeat each component twice before going on to the next one. So it's repeating 1 twice, and it says go on to the next one. It's repeating 2 twice, going on to the next one, and so forth all the way until it hits 5. If you use times instead of each, it instead goes through the entire vector first and then repeats that vector depending on the number of times you've indicated. So rep1:5 times equals 2 says, here's the entire vector one time, and here's the entire vector a second time. That's what happens when you set times equal to 2. Please note the differences between each and times. With each, it repeats each component that number of times before going on to the next component. And with times, repetition will occur after each iteration of the entire vector, rather than the component. Now let's talk about creating vectors from scratch. How you initialize a vector is using the C function. The C function I like to think of as standing for combine. Basically, you combine the numbers 1, 2, and 3 in this example into a single vector. And let's go ahead and run this code. Press Control Enter. And what I've done is I've combined the numbers 1, 2, and 3 into a single vector. Please note that vectors can only be of one data type. Characters or strings, as you would know of in other programming languages, can be indicated either using single or double quotes around each value. For example, in the code, let's say I type in C, A, B, C. This would just be a vector of strings A, B, and C. I'm going to press Control Enter. I'm going to scroll down, and I can see that the vector ABC has been created. It is very important to note that vectors can be only of one data type. If you mix data types in a vector, what will happen is that R will coerce the vector elements to the most general data type out of the ones that you have in the C function. For example, here we have in the C function a numeric 1, a string 2, the string indicated by the fact that we have quotation marks around it, and a numeric 3. Because strings are more flexible than numbers, these will all be coerced to strings, as you see here by the output. The second example I've posed here is the following. We have a vector C with a Boolean true, a numeric 1, and a numeric 0. Booleans, by default, can be coded to numeric by assigning true a value of 1 and false a value of 0. And because out of these two data types, the numeric is more flexible than the Boolean, these are all coerced to numeric components. The 1 and the 0 are kept numeric, but the true is coerced to a 1. Lastly, you can change the data type of a vector entirely if you want. I'll let you execute this code on your own. We have here a vector 1, 2, and 3 of all numeric components. If I were to wrap this in as character and run this code, I would get a character vector or a string vector with just the strings 1, 2, and 3. Similarly, if I have this vector of strings 1, 2, 3, I can run as numeric on this vector and get a numeric vector 1, 2, 3 out. And that's really it for learning the basics of R. The last thing I want to leave you with in this video is that pandas is the package in Python that would work with the Python equivalents of data frames and vectors. Remember in R that data frames are two-dimensional objects that consist of rows and columns, and vectors are one-dimensional objects. In pandas, they have very similar data structures, but the terminology is slightly different. In R, what you know of as a data frame is called a data frame as well in pandas, except data frame is one word. Also, the equivalent of what is known as a vector in R is known as a series in pandas. So just know that when you try to transfer this knowledge from R to Python using the pandas package, the functionality is very similar. However, the terminology is slightly different. As usual, please do not forget to save your code and to go back to git bash in your DSci 2000 folder, commit what you have in here, and push it.